I got 3.4. Yes, get it. Thank you, sir. Hot lagi.
Dessert.
Everybody did the sign attendance?
Yep.
Itu di mana? 3.8 is a B. 3.8 is a B.
If you don't get 90, that's going to be
3.8 is like 90. 3.8 is not 90.
if you want to really check that. No, pokoknya 90 is like 4 point.
Oh my god.
90 is a 4 point. So 4 point.
Yeah, I got
Around 80 is like,
this.
around 80 is like 3 point something.
Doesn't GPA only go up to 4?
Yeah, 90 is like 4.
Oh.
90 to 100, all 4. Punya 4.
Okay, is everybody here in the attendance? Okay. Okay, here comes the remedial quiz. Arya. Jack. Raditya. Raditya.
It's not here.
Farel. Gabriela. Samuel. Ervin. Gilbert. Fatima. Matthew. Liminghen. Tristan. Joshua.
Yes.
Daniel. Daniel. Huh? Finally, yeah.
Yeah. Oral it's like
Michael. Jason. Jason. Hold on. Excel.
I'm not confident at doing
Excel.
Bro, Excel.
I don't know.
Excel.
And you are? Excel. Pandu. Steven. 20. Fasya. Aisyah. Maxwell. Benhin. Benhin.
Oh yeah, MK.
April.
LK is basically
April. Valence. Askar.
Not confident.
Caleb. Sultan. Azhar. Russell. Russell. Anyone not getting theirs?
Chill, kids, chill. Masih satu.
Yesterday, who did the problems on the board? Not yesterday, last week. How much did you get? So, not sure why you don't want to do it on the board because you know the impact on the remedial quiz. So, I guess it doesn't matter that much to you guys. I've had my young days. I know. I mean, I didn't give them 100 because they do it on the board, right? But because they understand.
I get 20 on the remedial quiz because I don't understand.
Because you don't want to learn on the board. Okay, so we need to do a few exercises today on frames and machines. I think we did a little bit last time. Let's do more problems because the final exam will basically be frames and machines. Okay? So these kind of problems. So the final exam will be 2 problems and I think both of them will be like this. Both problems. I don't know, maybe I'll do one truss like what you just did. You want to do trusses?
I don't mind.
No?
I don't mind.
2 problems on this, 1 problem on truss. How about that?
3 problems?
You got 2 hours.
How long do we have?
2 hours.
How?
That's a long 2 hours. Huh?
What are the options? What are the options?
I need
120 minutes, 40.
Option A, 2 problems on these types, frames and machines,
Oh, yeah, well.
Oh.
right? Or 2 problems on this plus 1 problem on trusses. What you just got back. I mean, if you do 3 problems, then this might actually help you, I think. Like if you feel more confident. Who is more confident with trusses? No? Nobody? Okay.
No, it's
1/3 of
some
you?
people.
Yeah.
How about you?
Because that might actually help by distributing the points to 3 problems.
I guess.
Yeah. Okay. All right. Let's do a couple of exercises on these. Did we do this one? I think we did. No. Okay. All right. Let's do it then. By now, I expect more initiative from you guys. So tell me how to proceed. Okay, so the pruner multiplies the power from the forces here to this one. I think we did something similar though, like 2 weeks ago, right? Open your notes. What problem was it? Looks, I mean, it's also a plier, right? It's a plier mechanism like this, but it's a bit different. So basically, given these forces, what's the force, what's the cutting force there? Okay? So, what do you want to do? This is one body here. Right? This is one body. This is one body. You got the link at C, linking this handle with this handle. And you got the pin at B, linking this handle with this link. And then you got the gray opposite side, right? So the other side of the cutter. So what will be the first step? Draw this. What will be the first step?
Free body diagrams.
On which one do you want to do it? Remember, this is my ultimate outcome.
Between F and B.
F and B. So ABF, you want to do ABF?
Yeah.
Okay. So okay. So that's ABF. Let's draw all of this, right? Just for the sake of exercise. Here, you come up and put the forces there. Now, what is special about link BE? Tell me about link BE. What's special about it? It's a two-force member. So what's the consequence on the three-body diagram? Put the point B there. Yeah. So because of that fact, what's the consequence on point B? You see what he's drawn? Only one unknown, just a single force at that direction. So you know the direction. Don't draw dx dy. In contrast, what about C? Oh, go ahead. The unknown will be 2, Cx and Cy. Because it's not a two-force member here. I mean, you're not linking to a two-force member. Here, the link DE is a two-force member. So if I draw link DE, what is the free body diagram like on link DE? Okay, notice at B. Why do you draw it in this direction?
Because it's on opposite like that.
But what about this? Its relation to this. Before you draw that, I mean, a two-force member can be tension or compression, right? Why do you not draw it like, like this? And this. That is also valid, right? He's assuming intention, but there is another reason, a more important reason why. Look at that. Look at this arrow. So, yes, equal and opposite. So if you draw FB like this, then here it has to be equal and opposite. Go ahead, redraw what you've drawn. Yes. Okay, is that clear? Okay. What about the link at C? Now, there is also then the point C here, right? This is point C. On this handle. So, if he draws CX and CY like this, then over there, it has to be the opposite direction. Okay, make your arrow a bit bigger. Like, yeah. Okay, finish the free body diagram on the upper handle. You got the point B. Now, because we don't have point B yet, anywhere along the other bodies, it's really up to you how to define it. Okay? Okay, so he defined Bx and By like that. Now, draw the free body diagram of the gray cutter. Yeah, on the right hand side. Okay, you can have a seat. Let me have somebody else. Okay, Stephen, you want to give it a shot? So on the cutter, we have A, B, E, right? Okay. At point B, you have to refer to the other body, right? It has to be equal and opposite, because that's the linking between that handle and this. Label your forces. X and Y. Okay, what about E? Which direction should it be? This way. Okay, what is the next body after this? That lane, right? And so, this is point E. Yes. Okay, does everyone see that? Oh, you want to split that? Okay. Well, usually I don't split it until you get to the equation, so it's not confusing. Okay, thank you. So, everybody understand how the connection points have to be opposite? Okay, if you draw this wrong, then everything else will be wrong. Okay, does anyone have any feedback about the point A? Any comment on that, on what he did? What kind of contact is that? Roller. It's not a pin. Okay, so a roller will have one force, which is normal to the contact point, right? So it's like this. A point contact, it slides on this board, right? It only resists in one direction. And I would also draw it upward like this because it's cutting. Okay, it's cutting this wire. It's a wire, by the way. I mean, you're just looking at it through the board. Yeah. It cuts the wire, so the wire actually resists the cutting. So on this upper cutter, the wire actually put a force upward, right? The cutter cuts downward. The gray piece cuts downward, but the wire actually resists upward. So if you are the cutter if you are the cutter, you would experience a force downward or upward? Upward, right? So I'm stepping on the floor. The floor is pushed down by my foot, but my foot experiences a force up from the ground. Get it? Okay? So it's cutting the wire. It's cutting the wire downward, but the wire resists upward. Okay? So you can imagine that. So the force is like this. And it's only one because it's a point contact. Okay? We have actually a piece on A, but we don't have to do this. Okay? Sorry, that belongs there. That belongs to the upper handle. It's one piece with the upper handle. So, we're missing one. Because the lower cutter cuts upward and the wire actually resists downward. So,
Sorry.
yes,
In the free body diagram at point C, why does CX going down?
Y is, oh, the label you mean. Huh?
Yeah.
Yeah, just labeling. Up the force, 20 newtons. So, yeah, make sure you got everything on your free body diagram. Otherwise, your equations will all be messed up. This is really the key milestone in doing these kind of problems. Is breaking down the components and then drawing the forces. Questions? For fun. If I draw the free body diagram of the wire, what would it be? The wire. Uh-huh. Exactly. That's how it's cut, right? So if you are the wire, you are being compressed. But here, you are resisting the compression until you are cut, of course. But before the wire is cut, it resists. Questions? Come on. I need you to ask questions. Otherwise, I cannot know whether you understand or not. Which force is the hardest to imagine? Which one?
I don't understand.
You don't understand?
I don't understand.
You didn't understand which part?
The question.
Oh, the question. So which part of drawing this free body diagram is the hardest for you guys? This one? Is it because it's hard to imagine the body?
Yeah.
I see. So it's hard to kind of disassemble the mechanism, is it?
Sorry, it doesn't matter if we put the wire in the free body diagram at that diagram.
This one?
Yeah. Doesn't matter or does matter?
This AY?
Yeah,
It does matter. It has to be there.
it has to be. So I can put the wire there.
You must.
You must.
No, because it's drawing at the wire, the free body diagram in Satunya. So I put either one is okay.
No.
No, you have to have both, here and here.
Oh,
Use this up.
Because it's cutting both directions.
so I put wire there and there.
Not sure I understand. Repeat again.
Jadi di situ aku kasih wire-nya juga atau?
Dikasih wire artinya gimana?
Yeah, I draw it that.
Uh-huh.
Do I draw both? Dua-duanya aku gambar wire-nya atau salah satunya dulu?
Dua-duanya.
Dua-duanya.
Gambar wire-nya. Jadi kalau digambar wire-nya artinya gimana? Maksudnya begini gitu.
Yeah.
And then what's the force like?
bawah.
Like this?
Yeah.
I guess you can. So you're drawing two bodies in one free body diagram, you can. But generally not a good idea. I mean, this is like, there is actually, if you do this, let me draw it bigger. So if you do this, there is a force actually from this guy, right? Because it's here, right? So you are eliminating that force. The one in red is there, but it's internal. And because you draw your boundary, including the wire, then this red forces does not exist because it's internal to it. Does that make sense? So yes, you can do this. But for the sake of learning, I want to make it simpler and just separate the wire. I would rather separate the wire because mechanically it's also two separate body. Okay? You know, it's like, I mean, if you take mechanical engineering as your major and you take more advanced courses, you can actually do a method of section here. So if you do that, there is an internal force like that. But this force is internal, so if I draw the entire body, you see I have this force and this force and this force. You understand? So in any mechanical object, if you cut it imaginarily, inside there are forces. And if that force actually exceeds the material property, it will break. That's by definition the failure point. Okay? You will actually learn this on the next course. Now I remember. So even though you're not purely mechanical engineer, but you will take, this is called strength of material. So this is next.
Strength of materials.
In
But,
the dealing with the internal force.
what do you mean strength of materials?
The next course in the
Course of
curriculum
engineering static.
after engineering statics. Correct. Okay, time to do the equations. Yes. Oh, okay. Assume the contact surface at A is smooth, meaning like it's a point contact, it's sliding. It can slide, meaning there is no AX. So AX is here. That's what it means. Okay? Okay, let's do the equilibrium. Let's do it on. Okay, what's the strategy? Give me some strategy. I want to know AY. I know F. How do I find AY? AY exists here and here, so you need to trace your way from the known to the unknown. You want to start here or you want to start here? This is your known. So if I start here, my link is here, right? FDE. So if I solve FDE, it connects me here and here, right? So let me do that and we'll review what we did, okay? So here, I start from the known. So my target is to solve this guy. I'm not interested actually to solve Cx and Cy because it's not relevant to me. So how do I solve FDE? CD what you want to call them. G. This is point G. So I want to solve for FDE. I know this is 20. What do I do? Sum of moment at C. Because
CX and CY.
you'll get rid of CX and CY. Okay? So you have the counterclockwise. Okay, this is my pivot point. Counterclockwise 20 times 150. This is the distance, this point C. Okay, 150. This is FDE. So I have FDE. I have to split it into two. But you see, I'm not drawing it exactly right, but this is horizontally on the same plane, right? So this FDE X actually does not create moment. So it's just FDE Y, which is FDE sine of 45 times 25. Okay? 25 millimeters equals 0. So FDE is 169.7. Yes.
Should be plus.
Oh, yes. The way I've drawn it. Okay? So now, this FDE will link me to here through this VE link, right? So now, here is just a two-force member, so just ignore, I don't need to do any equation on that. So this FDE is the same, and with this FDE. So I'm gonna do the body, this is what do you call this, A, B, E? Yeah. Okay? I want to solve for AY. I know FDE now, 169.7. What do you do? Some moment at B. Because I'm not interested in BX and BY. So this is the pivot point. Now this is a bit tricky because you have FDEY here and FDEX, both of which creating moment about B. Okay, so I'll have, okay, this is going to be a bit long. So sum of moment about B. First of all, we have AY, so that's clockwise. So AY times 60. The distance is 60. Now I have FDEX. So I have this one creating clockwise movement. FDEX times, what's the distance? 10. Okay? Does everyone see that? This distance is 10 on this gray piece. And then I have FDEY. That will be another clockwise. This guy. Okay. What's the moment arm of FDEY? get that from?
C and B are in the same spot,
Mhm.
and the distance between C and D is 15.5.
So this is FDEY. Okay, this is my pivot point. This is my distance. Okay? Are you still with me? Yeah? Okay. Now FDEX is FDE times sine or cosine, doesn't matter. And I'm going to substitute the numbers directly, okay? So it'll be minus 169.7 cosine 45 times 10 minus, I know it's kind of annoying with this minus, but I think it's still the best way, because then you just do it with no thinking. Just carry all the signs, and you'll solve AY. Okay? What I want to highlight is we solve for negative here. Don't change the arrows. It's already negative here. The drawing should be consistent, right? It's this way here, this way, that way, and this way, right? Always equal and opposite. And then when you do the equation, you have to put in and carry the sign. You gotta carry the sign, because our assumption was already like that. Okay? The first negative is due to what? This first negative is due to
It's going
the direction, right? It's clockwise. But the second negative is because we solved it to be negative with all these assumptions. See, the problem is you cannot know what it will be like unless you are a mechanically genius person that kind of pushing this way, right? I mean, sure. But most of us can't. I'm too lazy to do that. So I'm just going to draw the arrow this way, and then this way, this way, this way. Okay? Whatever it will be, whether positive meaning I made the right assumption, or negative meaning I made the wrong assumption, I don't have to correct my assumption. Just carry the sign through and you'll be consistent. That's my method. Okay? If you want to flip the arrow, let's say you find this to be negative, and then you erase this, and you do it, and you flip it, then you have to flip it here, flip it there, and flip it here. You can do that. I mean, if you really know what you're doing, I'm fine with that. But I don't suggest that. Okay? It's very hard. So we solved the problem. Two equations. Without solving Cx, Cy, dx, and dy. I mean, the free body diagram looks complicated, but if you are strategic, then you don't have to solve these elements. Okay? This one is similar, so I'm not going to do it. Let me do this one. Any other questions on the previous one? On this? Okay, let's just keep exercising. We have a scissor lift. A scissor lift meaning you push here and it raised up this platform. Okay? This is usually done in industry. Like you have a truck with a height, and you want to load the stuff easily onto the platform, and then you can lower it to the ground level, and then you can take it anywhere you want, right? Okay, so it's a scissor lift. Disassemble this in your head. You got the platform, you got this piece, you got that member, and you got the hydraulics actually pushing or retrieving. These are wheels, these are rollers. So you have a point contact here, point contact there, a pin, and a pin. Okay? Now, take a piece of paper and actually draw these free body diagrams. Exercise it. I'll give you 10 minutes to do it. Get the platform. Go ahead. Draw the everybody. Put the arrows down. So this is a point contact or roller, right? This is a pin, pin, pin. And there is a hydraulic force going this way. This is a hydraulic, let's call this F hydraulic. Okay, are you done? No? Okay, keep working on it.
Still trying to figure out where I originally hydroxylumers are only D and B, right?
By the way, it also says each side. So this is actually a two-dimensional representation.
Repeat, sorry?
This is the platform. You got
Problem is,
stuff to draw.
draw on two objects. X is still FX.
Like that.
Oh no, yeah, no, actually, okay. If we were looking at it from in F and B, then technically, if it's angled, even if it's angled, then it would still be 0 because it's only EX.
That makes sense? So you got two. Parallel.
G2 and G1 are supposed to go down, right?
And then you got the
Gravity on it. Let's go down.
hydraulics pushing
And only down, right?
in the middle. Iya, di tengah-tengahnya. Jadi hydraulicnya cuma satu.
It's a high body FCB, right? Could be.
Actually no.
Can use some force on that X to find out. Find out VX. This is a roller, right? Especially
No, hydraulicnya ada dua.
there's going to be forcing on the X axis. Use one with that egg and into X and A,
But basically you can do it only on one side. Basically, I mean.
I mean, if we use one with an A, of course it eliminates AX and AY.
Okay, let's do this. Point A is a fin, so you guessed it. It'll have two. AX and AY. Okay?
Goes up there.
You want to continue?
I think
Go on.
it's go down because of the weight difference. After the AY was
You reap the benefits.
Notice the AY is
Continue on the
I
platform.
mean, reset it, and then just make the other one equal and opposite.
Yes.
Only
Right.
because 16
Label
in the
it.
middle.
Label it.
Yeah, we have to find that out. We're not.
Yep, there is gravity. Wait. What about point B?
B.
It's a roller,
So there's
meaning um, well, think about it. This is the platform. The roller is pushing up. Right? The roller is supporting the platform. So if you are the roller, are you being pulled down or are you being pushed up? You're being pushed up, right? Yeah. Negative. Okay?
yeah, we are not. We are not.
Okay. Okay, let's continue on this member, ACD. Guys, ACD. Yep. B is also supported from the ground. Yeah. C is a pin. So that means
G2 is load of 85 kilograms.
X and Y.
G1 itu center of mass dan apa namanya?
Okay? So the other C will be equal and opposite. Alright. F. It's a pin. Alright. Good job. Thank you. So, we're just missing one, which is the hydraulic. This is the external force, right? I'm going to call it FDE, or the hydraulic. This is the external force. It's not from the pin. It's not because B is a pin. B is a roller. But there is a hydraulic force. So this is not BX, okay? This is the hydraulic force. Okay, so now I want you to do the equation. Let me give you some hints. We are trying to find what's our unknown. Determine the force in each of the hydraulic cylinders for equilibrium. So FDE is my unknown. Okay? What do we know? We know the load, right? Okay? This one is 60, 85. So now we want to find FDE. What do you suggest? Where do we start? We start from the node.
FDE.
We want to find
That's
this,
what we're trying to find out. FDE.
but this is our known variable.
Moment at A.
So what do I do here?
Moment at A.
Moment at A, we'll find
BY.
By. Okay, that's the first step. Next,
Sum of forces on the Y.
to find
AY.
AY. Okay. I don't know whether we'll need it. Let's explore our thoughts before we actually do it to save time. So we know By. Okay, so we know By here. Okay. Four unknowns. So I cannot solve that directly. But if I do a sum of moment on F, I can have a relationship between Cx and Cy, right? I can hop on here. I can also do a moment about this. And if I know Ay and Ax, which you suggested we do, then I also have another relationship on Cx and Cy, two equations, two unknowns. We can solve Cx and Cy. Okay? And once we know Cx and Cy, can we solve FDE?
Yeah, I think we could just do sum of forces on guys.
Okay. Sounds like a plan. Go ahead. Why don't you solve this one first?
Wait,
Okay.
instead
Do it as an exercise. 4. 5 minutes.
I would
You
take
can do
instead
this.
of 9.8.
So on the top platform,
We don't want to use 9.8. Gravitation. I don't want to use 9.8. I just want to use 10.
C-nya dari mana? C-nya dari mana Om? Kan kami sih ngomong oke.
what's your name?
For BY. For G2, the loaders of P5 times the distance, 0.8 times the gravitational line point. I got
Okay,
66.4.
you got your AX, AY. Okay, so on this one, on the platform, what do you guys do?
Ignore CY.
Sum of moment of A.
It doesn't
So we
really.
don't want to do something.
Okay, you got
So we have to use some
plus
I don't
BY.
want to use some moment.
Oh, no,
Distance is
I take general one, yeah?
3.
Okay, no.
And then
minus 85 times
Oh,
0.8.
oh, you have higher than me.
85.
Yeah. What?
85 is actually kilograms, so you gotta
Times by net times
times gravity,
times 0.8.
0.8, and then also minus.
60 times 2 times 9.8.
Okay. Alright. I like how you are actively contributing.
Is this